Hey guys, I'm gonna do course practice 3.8 geometry. Okay, let's go. Okay, over here, a car travels from a station X to a station Y, 460 meters away on a bearing of 210. The distance due west, the car travels 7 meters. Okay, first of all, usually when they give you angle, you have to draw. So let's draw this. Now 210. So this one's 90, right? 90, 180, 210 is gonna be like right here. This is 210. So all of this right here is 210. And this part right here is called station X. This part over here is called station Y. So a car travels from station X to station Y 460 meters away. So it's gonna be 460 right here. And we need to find the distance the car travels. So what you're gonna do is since this line over here, right here, makes a 270, because this is 210, this is a 279. We're gonna find this angle by doing 270 minus 210, which is 60. Then you put a line so you can determine the distance due west. Now to find this right here, we have to do something. So we have this angle, and we have a hypotenuse, and we have the long. So to do that, it's gonna be for this question, fill in the blank. From a lighthouse, ship A is at a distance of 20 miles on a bearing of 20. So we see an angle, we have to draw. So 20, it's nothing crazy, it's like this. So right here is 20. And ship B, okay, over here it says and ship B. If you see and ship B, you draw another line. So let's just draw very quickly. So 260, so 90, 90, 90 plus 90 is 180. Over here is 270, but we need 260, so it's gonna be like right here. Now, if they said and then, if they said and then, you have to draw continuing from this point, only continuing from this point. But since they said and, you draw a whole new line. So over here, all of this is 260. Now we know this one's 10 because 270 minus 260. And they need to find the distance between the two ships. So let me just redraw it for a clearer image. It's gonna be a line here, 20, a line here, 10. And between is 260, so like that. Okay, 20 miles on each, so we're gonna put 20 here, 20 here. Now to find the what's it called, the distance between them, we need to put a line connecting both of them. So let me finish erasing this. So we're gonna put a line like this. Now we know that 20 is right here and 10 is right here. To find this angle, you need to do 10, because it's this tiny part, plus 20, this tiny part, plus all of this right here. It's gonna be 90. So 10 plus 20 plus 90. Let me just clear all of this really quickly. So 10 plus 20 plus 90. Let me just draw it again. I'm gonna make it big so we can see. 9 here, 20, 9 there, 10. 20 here, 20 here. Now we want to find this big angle so we can do something. So first of all, we'll put the line here. It's a triangle, and we want to find this big angle. So we know that this part's 10, this part's 20, so, and then we have 90, because 90 is of course this part. So we do 10 plus 20 plus 90, which equals to 120. So now we know that this angle, let's remove everything. Know that this whole angle is equal to 120. It's gonna be hard to draw a triangle, but we know. So like this, and like this, and then like this. Yeah. So 120 over here, 20, 20. Now they want to find the distance between the two ships. This is gonna be it. So I'm gonna call this triangle ABC. I'm gonna call this part AB. So to find this from doing the 3.7 video, we know that we can use cosine rule. So it is AB square equals 20 square plus 20 square minus 2 times 20 times 20 times cosine 120. And you get the answer, you radical your answer, and you get 20 radical 3. So that's the answer for the first one. Okay, for this question, they give you a really good, not like clue, yeah, like a hint. They tell you angle of elevation. So angle of elevation is usually directed upwards. So it's like this. Okay. And they said the angle of elevation of a vertical tower T from a ship is 17. So the ship is going to be right here. Let's call this ship. And the tower is like, let's just draw a tower. 17 degrees, so 17 right here. The ship is sailing 400 meters due east. So 400 meters, it's going to be here, because east, of course. The height of the tower is something meters. So to find it, you have the adjacent, because this one's the hypotenuse. Right here is hypotenuse. We don't want that, because we have adjacent and we have the opposite. So we're going to be doing tan 17 equals, tan is opposite of adjacent, so we're going to do x over 400. Tan 17, they said we can use 0.31. So 0.31 equals x over 400. And then you do 400 times 0.31 to find x. And you get 124. 121. Yep. Okay, for this one we need to zoom in a bit. Now, wait, let's read first of all. As a fraction in lowest terms, what is the tangent? So tangent we know opposite over adjacent of the angle between the plane ADZY and the plane ABCD. So ADZY, like this one right here, and the plane ABCD, it's gonna be this rectangle down here. Now, if you can envision it, you can use this angle and you can use that angle over there, but we're gonna use the one in front so we can see a bit better. Now, this angle over here, we're gonna get this triangle, okay? So if you look closely, you can see a triangle with AYB. Do you see it? AYB. So you have the triangle AYB. And they said AB is 15, and they said YB is 8. To find this angle, you do 8 over 15, and then you do tan inverse on your calculator. And that's how you get the answer. But over here, they want a fraction in lowest terms, and what is the tangent of the angle? If they said what is the angle, then you do tan inverse on the calculator. But for now, it's 8 over 15. Okay, for this question, we need to find AN. Okay, now first let's read it. O is the center of square BCD, and A is vertically above O, and is the midpoint of segment ED, BC. Okay, so AN. To find AN, we're gonna connect it right here. Now let's just redraw the triangle we have. This is A, E, N, right angle. We don't know AN, so we're gonna keep it X. So it said ED is 10. Because we need to find first of all of it. So now we know ED, all of it is 10. Now they said that N is the midpoint. Midpoint is middle, so we're gonna have it, so it's gonna be 5. And AE is 13. So then we have to do Pythagorean theorem, you get 5 power 2 plus x power 2 equals 13 power 2. And you get x to be 12. Okay. Okay, area of face AED. Now to find area, And since we already have the height, which is an, we're going to do 1 over 2 times base times height. And we know height is the answer we just got, which is 12. So 1 over 2 times height, we'll do height first, which is 12 times base. Base is gonna be right here. And I said before AD is 10, so 10 right here. 120 over 2 equals 60. Okay, the total surface area of the pyramid is equal to something. Now, since we found the area of face AED is 60, that means all the other triangles are going to be 60. A pyramid has, in this pyramid, it has 4 sides, 4 triangles. So we're going to do 4 times 60 equals 240. And then they said there's also a square. That square is BCDE. And to find the area of a square, we need to do side power 2. And they said it's 10. We do 10 power 2 equals 100. So you have 240 plus 100 equals 340. Okay, this one is the trickiest part, but we can do it. Okay, so the cosine of the angle between the two planes EAD and BAC. So EAD. So EAD is this part, and BAC is the triangle behind it. Now that angle, if you can imagine it, it's right here. So let me remove everything. So we have this angle. I don't know if you can see it, but anyways, you're gonna have it like this. I will draw the triangle. So you have it like this angle right here, yeah. So this angle. And we found the value of AN was 12. And we found, well, we didn't find, but this one, let's call it M for now. So AM is going to be 12 as well because it's a midpoint. And we know that NM is 10 because that's one of the sides of the square. So that's 10. Now they want the cosine. Cosine, we have to do cosine rule. So to find the cosine, we're going to do cosine x equals 2. Now we have to get the sides in between, so it's 12 power 2 plus 12 power 2 minus the opposite side, which is 10 power 2 over 2 times the first two sides, which is 12, and you get 288 minus 100, which is 188 over 2 times, so 24 times 12. 24 times 12 is 288. Okay, you have 188 over 288, and they want in a fraction. So let me just do it on my paper real quick. 188 over 288 divided by 2. 94 over 144, 94 divided by 2, 47 over 72. Okay, so you just have to keep dividing by 2 until you get a fraction you can't no longer divide. So my answer was 47 over 72. Let me check if that's even right. Yeah, okay, good. Okay, ABCD is a regular tetrahedron. Now, regular tetrahedron means it has equal sides everywhere. Of edge length 12 centimeters. AH is the height from vertex A. Okay. Now they want AH now. Now this one is really, really tricky because you have to do a lot of steps. But first of all, we are gonna do something. First, we are going to find the length of the, I'm gonna call this M, dm. And this is gonna be an altitude. Now there's a rule back in grade 8 we learned, and we're gonna apply the rule here. So put H here because that's the right there. And we're gonna put B, we're gonna put D, we're gonna put C, and we're gonna put M right here. Now we're gonna put a line right here. Okay. Now we have like a mini height for that one. So we're gonna have to do DC is 12. Now since it's like a midpoint, we're gonna do 12 divided by 2, which is 6 on this side. And now we have again Pythagorean theorem, so right angle over here, 6 power 2 plus x power 2 equals 12 power 2. Let me do it quickly. So 144 minus 36 is 108. So x power 2 equals 108. And x equals radical 108. So it's 6 radical 3. Okay, let me erase this. This part has a lot of steps and you could get lost very easily, so you have to just watch out. But in geometry exams, always draw so you can always understand. Okay, so now we know that, let me draw it like this now. The same triangle, so B, M, C, D, and H right here. So now we know that DM equals to 6 radical 3. Now you have to remember this specific rule where when you have an altitude, the longer part, so DH in this case, not HM. So HM is the shorter part, DM is the longer, DH is the longer part, DM is total. So you have to remember this rule that the longer part, you have to do 2 over 3 times 6 radical 3. That's how you find the longer side. To find the shorter side, you do 1 over 3. So 2 over 3 times 6 radical 3 is going to equal 4 radical 3. So now we have 4 radical 3, which is DH. So now let me clear everything. What the heck is that? Okay. So now we know that right here, DH is 4 radical 3. And we know AD is, of course, 12. Now I want to find AH. Since AH is a height, it's going to be right angle. So now we do Pythagorean theorem again. You're going to do 4 radical 3 power 2 plus x power 2 equals 12 power 2. And you get your answer, and it's going to be 4 radical 6. I just don't want to do all of it. If A, or if alpha, is the angle between AB, so you don't see the A, but it's right here. So AB and the plane BCD. So it's of course going to be this angle, that's obvious. Sine, okay, sine. Now, what to do here is we're going to actually connect them. So we have this triangle right here. This 12, we want this angle. So actually, is it this one or let me keep going. H 4 radical 6. Sine is it opposite over hypotenuse? So 4 over 12. So is it 1 over 3 radical 6? Is it? Oh, dang, actually, okay. Okay, I'll re-explain this part because I was a bit lost. Okay. So they said AB and they said BCD, which is the whole triangle down here. And so I figured out that the angle was right here. So that I drew it a bit wrong. This is supposed to be here. But I know that it's this angle, so I got this triangle, I put it here. And then by already knowing from previous stuff, I made this triangle. is 4 radical 6. Over here is 12, and over here is x. You do Pythagorean theorem. No, not Pythagorean, my bad, not Pythagorean theorem. They want sine. Sine equals opposite over hypotenuse. Hypotenuse is the one facing away from the right angle, which is going to be 12. So you have 12, and you have opposite, which is opposite to this angle right here. So it's 4 radical 6. You simplify, you get 1 over 3 radical 6. Okay, for this one, they're asking if theta is the angle between any two faces of the tetrahedron. Now, you can use any, but I'm going to use the easiest one, which is going to be this side and this one right here. Now, the angle between them is like right here, somewhere like this. Okay, wait, I'll draw it very quickly. So, it's like this one right here. Oh, again. This right here. Okay. So to calculate it, we know that AH is 4 radical 6. And they said they want sine. And sine is opposite over hypotenuse. And hypotenuse... what was hypotenuse again? 1 second. Hypotenuse was 6 radical 3. 6 radical 3 because I got, remember when I did all of it? Yeah, the whole altitude thingy. So now you do opposite over hypotenuse. You have 4 radical 6 over 6 radical 3 equals to 2 radical 2 over 3. Let me make sure in the calculator. 4 radical 6 over 6 radical 3. Yep. Okay. Okay, for this one, it's extremely simple. So first of all, we know that side AN and side NB are parallel to each other. So right here, these are parallel to each other. So imagine it like this. So these are parallel. We know all of this is 100, and we know that the rest, that it's like this, is 40. Now, when we have parallel lines, the angles over here and over here are co-interior angles. So this one and the 100 are co-interior angles. So co-interior angles are supplementary. So we're gonna have 80 over here. So to draw it on this one, basically 80 is over here. So we know that 80 is over here. Now I'm gonna redraw a triangle to find AC. So to find AC, we have this one, and this one. So we have angle. Now we know that this is 80, this one's 40. To find the total angle, we're gonna add them. This is 120. And we have 4 here, we have 8 here. And to find AC, we're gonna do, of course, cosine rule. So you calculate it, you get 4 radical 7. Let me just do the rule for you guys. 2 equals 4 times, oh my bad, 4 plus 8.2 minus 2 times 4 times 8 times cosine 120. Yeah. Yeah, pay for it. Yeah. So you get the answer, then you have to radical the answer, and then you get 4 radical 7. Okay, now they want sine CAB. So we're gonna draw it over here so I can do something. They give you this line, all of it is 100. You have 120 over here. I'm gonna do all of it. So 4, 8. See here, a line. I'm not gonna put the NB line. Okay, ACB, and we know this line is 4 radical 7. Now we want to find this angle right here. To find this angle, you have to do sine rule. So you can do whatever. You can do 4 radical 7 over sine 120, or you can just flip it and you have to do the other one with the sign on top. So I'm going to do both ways. So I have 4 radical 7 over sine 120 equals 8 over sine x. Now you could also do sine 120 over 4 radical 7 equals, oh my bad, sine x over 8. Either way, you're gonna get the same answer, so it doesn't matter as long as you have the same ones on the numerator. So if sides on numerator here, sides on numerator here, if angles on numerator here, angles on numerator here. Okay, so it doesn't matter at all. So you have to do, I'll do on the first one, sine 120 times 8. We're gonna cross multiply over here. Sine 120, answer times 8. And then answer divided by 4 radical 7, you get radical 21 over 7. And then using the other one over here, we're going to cross multiply 8 and sine 120. 8 times sine 120, you get 4 radical 3, and then you get the same answer. Okay, so you get it. If they asked you, because right now we got the answer as radical 21 over 7. If they ask you for the angle, you're gonna go on the calculator, you're gonna do sine inverse. So sine inverse radical 21 over 7. Only if they ask you. You're gonna do sine inverse to find this. Okay, this one is super easy. So first, angle of depression. So angle of depression, so it's gonna be like this. Angle of elevation was like this, right? Angle of depression is gonna be like this now. So let's remove so I don't confuse you guys. So we have it like this, 42 over here. And the horizontal distance of the boat from the foot of the cliff. So of the boat, which is right here, from the foot of the cliff is going to be right here. So 100. You want to find the height of the cliff. So the height is going to be over here. You have a right degree angle. You're going to do, so they gave you sine, cosine, tan, okay? So 90, we have 42, we have 400. 400 is the adjacent. Okay, so 42, we have adjacent, we need to find opposite. 42 tan, because tan we want opposite over adjacent, equals opposite, which is x, over adjacent, which is 100, is 100, yeah. So now you do tan, oh, did they give you tan 42? Tan 42 is 0.9, 0.9 times 100 is 90. Okay, for this one, it's super easy, okay? So what is the value of z if y equals 100? So y equals 100, we're gonna replace it over here by 100. To find x, because we wanna find x to find z. So to find x, we're gonna use this 45. They give us tan 45 equals 1. We know that tan is opposite over adjacent, so we're gonna use x over 100. Tan 45 is 1. 1 equals x over 100. X equals 100, okay? Now I want to find z. To find z, we need to do, we're gonna just replace 100, replace x by 100 over here. We need to do opposite over adjacent. So we have tan 27. 27 they told us 0.5 equals opposite is 100 over adjacent. Adjacent is all of this, so we need to replace it by 100 plus z. Okay, now we're gonna distribute. We're gonna do 0.5 times 100 is 50 plus 0.5 z equals 100. We replace 50 other side. You have 0.5 z equals 50, and then z 50 over 0.5 is 100. Okay, I skipped question 10 and 11 because they're too simple. So the angle between the line PR, so we have PR, oops, PR, hold on, PR right here. Oh, that's a bad line. QSR, so QSR, and the angle between them, it's gonna be PRM, which is this angle right here, if you can see it. So PRM. Okay, for this one, they said the line QW, and they said plane PQRS. So it's gonna be this angle right here. So it's gonna be angle WQS. Yeah, perfect.